Hello students, welcome to my chemistry classes. Today we are going to discuss the one of the requested topics in the group theory, that is point groups. Before going to the point groups, we have to know about the Schonflies notation. So, what do you mean by Schonflies notation? In Schonflies notation, point groups are denoted by a letter symbol. It may be C, it may be S, and it may be D, or it may be other things. We are going to represent a symbol along with the subscript, okay, which is usually used in the crystallographic. We are going to discuss what do you mean by the Schonflies symbols, what are the different types of the Schonflies symbols. So what does it means? We can discuss it one by one. So on the screen you are going to see first one is the Cn, and second one is the Sn, and the third one is the Dn, and 4, 5th, 6 is the Ot and I. What do you mean by this Schonflies notation? What does this indicates? We can discuss it one by one. First, you are going to see the Cn. The Cn, which indicate means cyclic. You are going to operate the n-fold rotational axis. The Cn, which is usually indicates n-fold of rotation axis, where n is any integer. It may be C1, it may be C2, or it may be any C3 and higher number. Okay. This Cn number, which is further classified into three groups. One is the CNH, and another one is the CNV, and another one is the CS point group. CNH means you have to take the cyclic n-fold rotational axis. Along this one, you have to add the sigma H. What do you mean by this H or sigma H? The sigma H means the plane of symmetry, horizontal plane of symmetry, you have to operate perpendicular to the axis of rotation. If you are operating at the particular axis, you have to take this horizontal plane of symmetry perpendicular to that one. Then that becomes CNH point groups. And the next one is CNV point group. In the CNV point group, it is concluding the CN axis, that is cyclic group, as well as vertical plane of symmetry. Vertical plane of symmetry means it is always parallelly runs through the principal axis. Okay, it is always runs through the principal axis, or it is always runs through the n-fold of rotational axis. That is one CNV point group. And another one is the CS point group. CS point group means, okay, which is also represented by the just the symbol S, which means which is going to contain only the one mirror plane of symmetry. Okay, so finally what we can say, Cn is this one point group, cyclic point group, which is containing only rotational axis of symmetry. CNH, along with the rotational axis of symmetry, it contains the horizontal plane of symmetry. And CNV means along with the Cn, you are going to contain the vertical plane of symmetry. CS means only one mirror plane of symmetry. Okay, so next one is the SN axis of symmetry. So SN axis of symmetry is nothing but improper axis of rotation, or it is also called as rotation followed by the reflection. Okay, so it is usually it is the product of the Cn into sigma. We will discuss it in the later classes. Okay, so next one is the Dn point group. In the Dn point group, which represents, it is going to contain the dihedral plane of symmetry. Dihedral plane of symmetry means where the two consecutive axes is happening in a particular plane. Okay, so the Dn point group, which containing the n-fold rotation of axis of symmetry along with the perpendicular, means two consecutive C2 axis is present. This Dn point group is again classified into DNH. This Dn axis plus horizontal plane of symmetry, that concludes the DNH point group. DND means dihedral plane of symmetry along with this one Dn mirror planes are present, that is called as DND point group. Okay, next one is the O. So O, which represents the octahedron. Okay, so next one is the T which represents the tetrahedron, and the I letter which represents the icosahedron. These three Schonflies notation which includes the OH point group, TD point group and IH point group, and we are going to consider it as a higher point group. These are the Schonflies notation that we are using in the group theory to say the point groups. Okay, next we move on to the point groups. Okay, so when you are talking about the point groups, generally we are going to classify the point groups into two groups. First one is the low symmetry point groups, means these are all the point groups. They generally contain the less number of symmetry elements, only few number of symmetry elements are present. Next one is the higher symmetry point groups. Higher symmetry point groups means, for example, tetrahedral, octahedral and icosahedral. So this is generally containing higher number of symmetry elements. It is going to containing the 24 symmetry elements. Tetrahedral, octahedral will contain the 48 symmetry elements. Icosahedral which contains the 120 symmetry elements. That's why we classified it under higher symmetry point groups. Okay, so let us discuss one by one in this video. Okay, so first we can discuss the low symmetry point groups. See, the first one point group that is present in here is C1 point group. So okay, what do you mean by C1 point group? C1 point group is nothing but, so we have to, it is containing only one symmetry element, that is an identity element. Identity element is nothing but C1. C1 is equals to E. Okay, so we can discuss it in the later, what is the relationship between the symmetries elements. Okay, C1 is nothing but you have to rotate the molecule by 360 degree. 360 divided by 360, that gives us to 1, means n value is 1. C1 point group, it is going to contain only one symmetry element. The given example, I have given the example here. See, it is an chiral carbon atom, means all the carbon atoms, the carbon atom is substituted with 4 different groups. Hence you have to rotate the complete 360 degree to get the same structure. That is, it is containing the only one symmetry element. Except this symmetry element, it does not contain any other symmetry element. Get an idea? Okay, so next one is the CS point group. CS point group is nothing but the symmetry elements this are present is the identity element. See, one thing you keep it in mind, symmetry element E, it is every molecule in this universe has one symmetry element, that is an identity element. Okay, so next one is the sigma. Sigma means if you are going to consider the sodium, oxygen and Cl are in the plane of the paper, if you are going to slice this paper, this NaOCl is going to divide it into two equal halves if you are going to slice this paper. Okay, so then it is going to containing the one mirror plane of symmetry. Okay, only two symmetry elements are present. Okay, next one is the CI point group. CI point group means I have shown this example 1,2-dichloro, 1,2-difluoroethane. Okay, which is in the staggered structure, staggered conformation. In this case, if you are going the center at the center carefully, if you are going to observe the structure, I have put a dot in the this one and I have mentioned with I. If you are going to line a draw towards the fluorine atom which is above the plane, and if you extend the same line towards the below the uh, plane fluorine atom, okay, you are going to encounter the same number, same element. That is, an inversion center is present in this molecule. Means in this point group, the molecules will contain only two symmetry elements. One is the E, identity element, and another one is the I. Except these two symmetry elements, it does not contain any other symmetry elements. That's why we put it under CI point group. Okay, these are all the very low symmetry elements. Okay, so next we move on to the CN point groups. Okay, and I have given the notes in the description, okay, where you can download the notes. Okay, so next one is a CN point group. So CN point group generally starts from the C1. Okay, we already discussed the C1. C1 is nothing but only containing the one symmetry elements. That's why usually CN point groups commences with the C2 point group. Okay, so in this C2 point group, okay, the given example is the hydrogen peroxide. This hydrogen peroxide, where the two hydrogens are present below the plane. Okay, I have put the rotation also. Okay, if you are going to draw a line through this C2 axis, and if you are going to rotate along the clockwise direction, if you move 180 degree, you will get the same symmetry element. Okay, only two symmetry elements are present here. One is the identity element and another one is the C2 axis of rotation. Okay, so this C2, C3, all these are arrived from the Schonflies notation, as I said earlier. Okay, so next one is the C3 point group. C3 point group, it is going to containing the three symmetry elements. One is the identity element and another one is the C31. Okay, sometimes in some textbooks they are going to mention the C31, or some they are shortly they are going to give the C3, and another one is the C3 twice. Only these three symmetry elements are present. See, generally we can say the Cn point group, which is going to contain only the rotational axis of symmetry. It is not containing any other symmetry elements. See, it is reflected here. C2 group containing E and C2. C3 group is containing E, C3 and C3 twice. C4 group, see, look at the example. So they have given a structure. In that example, the compound containing the identity element C4 or C41, C42, C43. So only the rotational symmetry elements are present in this molecules. Okay, in the next video we are going to discuss the CNV point group. Okay, thank you.